Until 1977, electrode technology was basically unchanged. Then, electro-cap International introduced the ECI electro-cap electrode system. For the first time, a true recessed electrode was made available for clinical EEGs. This breakthrough has changed how the EEG test is administered to patients. Accuracy, speed, comfort, and ease of use has made ECI a leader in the industry. Today, ECI offers a variety of systems to help give your patients the most up-to-date technology in EEG testing. ECI has 3 sizes of InfoCaps available. The InfoCap 2 and 3 are standard with a modified infant electrode placement system. These can be provided with the full 10 to 20 system. The surgical style electro-cap is designed to be used without any straps. This cap is cut lower and has a different type of elastic around the edge. This cap has been useful in the ICU unit and other situations in which the patient cannot be easily moved. Any of the electrocaps can be made in the surgical style. Electrocaps are available for most brands of topographical EEG brain mapping equipment, with placement and wiring unique to each machine. Systems are available for brain mapping as well. ECI has the flexibility to make caps to your specification, with as little as 4 or as many as 135 electrodes on one cap. Caps and systems have also been made for custom research, sleep and long-term monitoring, ambulatory, telemetry, and animal research. ECI presents the patient preparation and cleanup using the ECI electro-cap electrode system. First, plug the color-coded electrode board adapter into the electrode board following this diagram. To begin the application, place the body harness around the chest and under the armpits. Fasten the Velcro straps together, making sure the snaps are in front and centered on the chest.
Okay, what we want is the strap to be snug, but we don't want it to be uncomfortable for you. Is it too tight right now?
No, it feels fine.
Okay, that's great. You can put your arms down and just lean back in the chair.
The circumference of the head is measured with a special color-coded measuring tape, or an ordinary metric tape measure. The tape measure is wrapped around the patient's head approximately 1 inch above the nasion and 1 inch above the inion, the prominent bump on the back of the skull. The color-coded tape will indicate the color of the proper cap size. When using a metric tape, the size range is printed on the label of each cap. The ear electrode is clipped onto the earlobe, similar to a clip-on earring. For the patient's and technologist's safety, rubber gloves should be worn during the rest of the procedure. Using the syringe plunger, inject a small amount of electrogel into the disc cavity. Holding the syringe with the dominant index finger and opposite forefingers to hold the electrode down, rock the syringe back and forth. Using moderate pressure, this will abrade the skin and reduce the resistance of the electrode. Follow the same procedure with the opposite ear.
Next step we're going to do is take a special measurement from the front part of your head to the back.
To assure proper placement of the frontal electrodes, measure for the FP line. Measure the distance from the nasion to the inion. This metric measurement is then noted by the technologist, and the decimal point is moved 1 place to the left. For example, 36 centimeters would result in a measurement of 3.6 centimeters. We would then measure up from the nasion 3.6 centimeters and mark the FP line. A similar procedure is used in finding the placements for the FP1 and FP2 electrodes. The noted head circumference of 59 centimeters would result in a measurement of 5.9 centimeters. Calipers are expanded to this resulting measurement and placed evenly between the middle marker. Lines are drawn vertically and horizontally on the extended FP line. Place the sponge discs over the FP1 and FP2 marks. These will absorb perspiration and reduce movement of the electrodes. We are now ready to place the electro-cap on the patient's head. set the FP1 and FP2 electrodes into the sponge discs on the forehead. Continue to work the cap on from front to back until it is tight on the head. Secure the cap straps to the body harness by crisscrossing straps and snapping them into place. Double-check that the straps have been pulled tightly and secured. This will reduce movement artifacts during the EEG exam. Work each electrode onto the scalp to move excess hair from beneath the electrode mount. Make sure that the cap is centered on the head and fits properly. Attach the blue connector end of the cap to the blue electrode board connector. At this time, connect the A1 and A2 ear electrodes into the appropriate position on the electrode board. Next, we will prepare the electrode sites. The syringe plunger should be filled with 3 to 5 cc's of electrogel. This is the normal amount needed to fill the electrodes in the cap. To fill, press the white mount against the scalp with the first and middle finger. Insert the blunt needle into the hole. Lifting the needle slightly off the scalp, inject the electrogel into the mount until a small amount of gel comes out of the hole. While holding down the electrode, place the opposite index finger on top of the syringe. Using moderate downward pressure, rock the syringe back and forth. The excess gel is then wiped off, and the process is continued until all the electrode sites are filled and scalp is abraded. Remember that light fingertip pressure is all that is needed to abrade the skin and obtain proper electrode resistance. Too much pressure may cause the scalp to bleed, which can result in persistent artifacts throughout the test. After all of the sites are prepared, the impedance of the electrodes must be checked. electro-cap International has specifically designed its cap systems to be adaptable with all major EEG manufacturers. This flexibility allows you to custom design your testing facility to your needs. A proper impedance reading should be below 3,000 ohms. To test the electrode impedance, turn the test switch to the first electrode and press the test button. This process is continued for each of the electrode placements. If any of the electrodes read above 3,000 ohms, the electrode must be refilled and the scalp reabraded until the proper resistance is obtained. If the electrode impedance remains above 3,000 ohms resistance, a quick insert electrode can be used. The quick insert electrode will bypass the faulty electrode on the electroboard adapter. Once the electrodes have been checked and properly adjusted, a neck roll is placed behind the patient's head. This prevents the electrodes from rubbing against the chair or bed, which can cause artifact during the testing. We have now concluded the electro-cap application. Here are the steps that we covered. Place the body harness on the patient. Measure the circumference of the head. Attach and abrade the ear electrode. Measure and mark the FP line. Place sponge discs on FP1 and FP2 marks. Slip cap onto the patient's head. Attach straps to the body harness. Connect the cap connector to the electrode board. Fill and abrade each electrode. Check the impedance of the electrodes. Place a neck roll under patient's head. During the testing procedure, problems may arise. Most electrode artifacts can be eliminated by simply filling the electrode and reabrading the skin. If the artifact continues, a quick insert electrode will be placed into the cavity of the faulty electrode mount. Tape is placed over the temporary electrode to secure the electrode to the cap. The faulty electrode jack must be removed from the electroboard and replaced by the quick insert electrode jack. The temporary electrode is then noted on the EEG tracing. If the resistance of all the electrodes is high, it is likely that the ground electrode must be reabraded. A pulse artifact can be caused by having an electrode placed on or near a blood vessel. To solve this, simply move the electrode mount slightly and refill until the resistance is down. With the EEG testing complete, we are ready to proceed to the cleanup.
Okay, we're all done with the test now. I'm just going to take this roll from your neck, and what we're going to do is take the electro-cap off and wipe all the electrogel.
To clean the patient, simply wipe the gel from the forehead, ears, and hair. Assure the patient that the residual gel will be eliminated by shampooing their hair. The electro-cap must be cleaned after each EEG for sanitary reasons and to ensure accurate readings. Before washing, unsnap and remove the straps from the cap. Fill the sink with cold tap water and a small amount of Ivory or Palmolive liquid detergent. Submerge the cap for a few minutes, making sure the blue connector stays dry. Use a cotton swab to clean the gel from the recessed electrode. Scrubbing the mounts will further remove any excess gel from the electrodes. Running cold tap water over the ear electrodes will clean them adequately, but periodic scrubbing will extend their life. When done, rinse the cap completely and blot gently with a dry cloth. Hang the cap to dry so that the blue connector is higher than the cap. Replace the straps when the cap has dried. The drying time is approximately 1 hour. electro-cap International has been recognized by the International Federation of Societies of EEG and Clinical Neurophysiology for its system's EEG electrodes. ECI systems are used in over 3,500 laboratories worldwide. Just like you, ECI is committed to giving the best technology to the public. Call electro-cap International at 1-800-527-2193 for more information on the right system for you and your patients.